This is just water. Plain, ordinary water. Nothing added, nothing special about it. But run a small electrical current through it and something remarkable happens. The water starts to come apart. Bubbles form at the electrodes, gas rises to the surface, and what you're left with is no longer just water. You've just made fuel. That's the premise of a hydrogen generator. And once you understand how it works, it's hard not to see water differently. The process behind all of this has a name, electrolysis. It's been known since 1800, when two scientists, William Nicholson and Anthony Carlisle, accidentally discovered that water could be split using electricity. They weren't trying to make fuel. They were just experimenting with a newly invented battery. But what they found changed chemistry permanently. Water, it turns out, is not a stable dead end. It's a molecule waiting to be unlocked. Water is two hydrogen atoms bonded to one oxygen atom, H2O. That bond is stable under normal conditions, but electricity disrupts it. When you submerge two electrodes in water and apply a voltage, the electrical charge begins pulling those bonds apart. The oxygen is drawn toward one electrode, the hydrogen is drawn toward the other, and both escape the liquid as gas. Watch what happens at the electrodes. On the negative side, the cathode, hydrogen gas starts forming almost immediately. Tiny bubbles cling to the surface, then break free and rise. On the positive side, the anode, oxygen does the same, just at half the rate. For every 2 molecules of hydrogen produced, only 1 molecule of oxygen comes out. That's the chemistry being exact. 2 parts hydrogen, 1 part oxygen, exactly matching the ratio locked inside every molecule of water. Pure water, though, doesn't conduct electricity well enough to make this practical, so a small amount of an electrolyte is added, often potassium hydroxide, sometimes sodium hydroxide, sometimes just a diluted acid. The electrolyte doesn't get consumed in the process. It just gives the electrical current a clear path to travel through the liquid. Without it, resistance is too high, the reaction is too slow, and the whole system becomes inefficient. With it, the process runs cleanly and continuously. The electrodes themselves matter more than most people expect. They need to be conductive, stable, and resistant to corrosion, because they're sitting in a chemically active solution while electricity passes through them constantly. Stainless steel works for basic setups. Platinum is ideal, but expensive. Titanium coated with other metals sits somewhere in the middle, durable enough for long-term use, affordable enough to be practical. Whatever the material, the surface area of the electrode directly affects how much gas is produced. Larger electrodes, more bubbles, more gas. This is why commercial hydrogen generators use stacked electrode plates. They maximize surface area without making the device enormous. Now here's the part that closes the loop. The hydrogen gas that rises off the cathode, once captured and collected, is a real, usable fuel. Not a storage medium, not a battery analogy. Actual combustible gas with a specific energy content. Hydrogen has the highest energy density per unit of mass of any known fuel. It burns hot, it burns clean, and when it combusts, it produces exactly one thing: water vapor. Think about what that means. You start with water, you run electricity through it, you split it into hydrogen and oxygen, you burn the hydrogen, and the only output of that combustion is water again. The cycle is complete. Nothing toxic, nothing left over. Just the same molecule you started with returned to the world. That's why hydrogen gets described as a clean fuel. The burning itself produces no carbon dioxide, no particulate matter, no sulfur compounds. The flame is nearly invisible to the naked eye. Hydrogen burns with a pale blue color that barely shows in daylight, and the heat it releases is substantial. In industrial settings, hydrogen torches are used for cutting and welding. In fuel cells, a different but related technology, hydrogen reacts with oxygen electrochemically to produce electricity directly, with water as the only byproduct. The challenge, and this is the part that matters for where we are right now, is energy input. Electrolysis doesn't create energy, it converts it. To split water, you need electricity. Where that electricity comes from determines whether the entire system is actually clean. If the electricity comes from burning coal, then the hydrogen isn't clean at all. It's just a complicated way to move fossil fuel emissions from one point to another. But if the electricity comes from solar panels, wind turbines, or hydroelectric sources, then what you have is genuinely carbon-free fuel. That version of hydrogen even has a name: green hydrogen. Right now, most hydrogen produced in the world is not made through electrolysis. It's made from natural gas through a process called steam methane reforming, which releases carbon dioxide as a byproduct. Green hydrogen, the electrolysis version, is still more expensive to produce, mostly because electricity costs money. But the gap is closing. Electrolyzer technology has improved significantly. Renewable electricity has gotten cheaper. And the pressure to find fuels that don't destroy the climate has never been more serious. What makes the hydrogen generator compelling as a concept isn't just what it does, it's what it represents. A world where the fuel cycle begins and ends with water, where surplus electricity from the sun or wind gets stored as gas, transported, and burned without leaving anything behind, where the exhaust from your engine is the same thing that falls from the sky as rain. The hands that set this up, the electrodes in the water, the wires to the power source, the gas collecting in the tube above, are running one of the oldest and cleanest chemical reactions humans know how to produce. 200 years after Nicholson and Carlyle stumbled onto it by accident, it's still the most honest answer to the question of what fuel could look like when we finally decide to do this right.